Today, I want to walk through how I integrated Stockfish into a Godot game without ever freezing the UI. The core problem is simple but important. Stockfish is an external chess engine, and it can take time to think. If you run that work on Godot's main thread, your game will stutter or completely freeze while the engine is analyzing. That is unacceptable for a real game. So the entire design is built around one rule. The UI thread must never block. Each AI turn follows the same flow. First, the game converts the current board into a FEN string. This is just a compact text snapshot of the exact board state. That FEN is the only thing the chess engine needs to understand the position. Next, the engine analysis is kicked off in a background thread. This thread is completely isolated from the scene tree. It is allowed to block, wait, and do heavy work without affecting rendering or input. The engine itself is not run directly inside Godot logic. Instead, a small shell wrapper controls Stockfish. This wrapper speaks the UCI protocol and manages the engine as a subprocess. Using a coprocess keeps input and output streams clean and prevents deadlocks while Stockfish is thinking. Commands are sent to the engine to configure its strength, analysis depth, and how many candidate lines it should calculate. Then the current board position is sent, and the engine is told to begin thinking. While this is happening, the game keeps running normally. Animations play, the UI remains responsive, and nothing feels stalled. When the engine finishes, the background thread stores the result. However, Godot does not allow threads to directly touch the scene tree or emit signals. To stay safe, the thread schedules a callback to run on the main thread instead. Once execution is back on the main thread, a signal is emitted. That signal wakes up the async logic that was waiting for the engine result. This pattern lets us write clean, readable async code while still respecting Godot's threading rules. Now comes one of the most interesting parts: MultiPV. Instead of asking Stockfish for only the single best move, the engine is configured to return multiple strong candidate lines ranked by quality. This gives us a list of plausible moves, not just the optimal one. Those results are parsed into an ordered list, from strongest to weakest. The key idea is that these are still good moves. They are not random blunders. They are simply less optimal alternatives the engine already understands. This makes difficulty tuning much more natural. At low levels, the AI intentionally chooses from weaker candidates more often. At higher levels, it increasingly locks onto the best move. The randomness is controlled, meaningful, and grounded in real engine analysis. This feels far better than pure randomness or simply lowering engine strength. The AI still plays smart, just not perfectly. The final selected move is then translated from engine notation into board coordinates and executed in the game. The result is a hybrid system. Godot handles the game loop and UI smoothly. Stockfish provides real strategic intelligence. Threading and signals keep everything responsive and safe. This approach is powerful because it combines clean async patterns, external process control, and intelligent difficulty scaling, all without sacrificing performance or player experience. That is why this system is worth a deep dive.